Two-variable statistics by Elizabeth Uklis, Jordan Stevenson, and Sophia Huck. Correlation, the relationship between two variables. Characteristics of correlation: direction, linearity, strength, outliers, and causation. Direction. When the graph has an upward trend, the correlation is positive. When the graph has a downward trend, the correlation is negative. When the graph is scattered, there is no correlation. Linearity. Do points follow a linear trend? The linear trend shows if the points follow a straight line. In the first example, it is linear, as well as the second example. However, the third example, there is no linear relationship. Strength. Keywords: moderate, strong, or weak. A positive or negative correlation is characterized by a straight line with a positive/negative gradient. The strength of the correlation depends on the spread of points around the imagined line. The first example shows strong positive, the second moderate positive, the third weak positive, the fourth strong negative, the fifth moderate negative, and the last one weak negative. Outliers. An outlier is an isolated point that does not follow the trend of the rest of the data. If there is an outlier, it should be discarded. Causation. Correlation does not mean one variable causes the other. If there is a change within a variable which causes a change in another variable, that would be described as a causal relationship. Characteristics of correlation can be inaccurate, so as a method of precise measurement we use the Pearson's product. Moment correlation coefficient, which is defined as R. The sign of R indicates the direction of correlation, positive or negative. The size of R indicates the strength from -1 to +1. Correlation charts. As you can see here, these are described by positive and negative correlation. Here's an example. For each of the scatter diagrams, describe the relationship between the variables. Consider the direction, strength, and linearity of the relationship as well as the presence of outliers. The first is a negative weak correlation. The second is a positive strong correlation. The third is a positive moderate correlation. Line of best fit. If correlation is strong and linear, we can draw a line of best fit. To do this, we must calculate the mean of x and y values. We are able to draw a line to the mean point once we have it calculated. Here is another example. 9 cats were left in a house alone while their owner was gone. The length of each cat took to eat was recorded, as well as the amount eaten. Calculate x and y. So you basically find the mean of the time and the amount to find x and y. Linear regression. Line of best fit differs from person to person, so we use linear regression to find the line that best fits the data. We can find the vertical distances d1, d2, d3 between each point and the line, and then we square each of these distances to find the sum. Here's another example. From the last example I described, here's what you do. A. Draw a scatter plot, and B. Use technology to find the least squares linear regression line. As you can see in B, using technology, I found out that y equals 0.53x plus 4.23. The chi-square test of independence. The chi-square test of independence determines if two variables from the same data are independent. In some cases, two variables could be dependent. All the variables are placed on a contingency table. Contingency tables have degrees of freedom, which are values which are free to vary. Using the chi-squared expectations also go on the expected frequency table. The significance level also determines whether the variables are independent or not. Here's an example. A survey was given randomly in an office space determining what kind of coffee the employees liked best. The contingency table shows the results. At a 5% significance level, test whether the kind of coffee is dependent on gender. Here's the example continued. Null hypothesis. Coffee type and gender are independent. Alternate hypothesis. Coffee type and gender are dependent. The degree of freedom is 2 minus 1 times 4 minus 1, which is 3, and the significance level is at 5% or 0.05. The critical value is 7.81, and here are the results from the expected frequency table. Using technology, I found out that xcalc is 13.45, which is greater than 7.81, and so we reject HO, which means that we conclude at a 5% significance level the variables coffee type and gender are dependent. Real-life example. Scientist Henry von Horst conducted a longitudinal case of 100 people, 50 left-handed and 50 right-handed. His goal was to prove a correlation between the death rates and the dominant hand usage, hypothesizing that left-handed people typically die at a younger age. Horst calculated the amount of people who lived to age 66 and from there counted the amount who lived to 75. And here are the results on the table. Here is a video that shows step-by-step explanation of the chi-squared test. And so here begins your quiz. I will go through each slide. Feel free to pause the video so you can write down the question. Thank you for watching.